Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And this is basically the same set of puzzles that I worked on yesterday, but this is the Kropki version, which is the bad Kropki version. So take that easiness with an extra grain of salt because it was considered easy as a set of puzzles for the bad Kropki, the bad German Whisper, which I did yesterday, and there's a bad Sudoku. I don't think I'm going to be doing that on the channel because it's not that different from normal Sudoku. Anyways, here are the rules. And this is Bad Kropki by Michael Lefkowitz. And here are the rules. Normal Sudoku rules apply, which means fill the entire grid with the digits 1 through 9, such that there are no repeats in any row, column, or designated 9-cell region. So that's normal Sudoku. And then we have Bad Kropki, where digits separated by a dot are either consecutive or in a 1 to 2 ratio. I made some dots black and some white so that it looks pretty. So basically, if this were, say, a 6, this would have to be 3, 5, or 7. Because the digits that, the dot separates digits which could be either consecutive or in a 1 to 2 ratio. And since 6 is in a 1 to 2 ratio with 3, and it's consecutive with 5 and 7, that's why this digit here could be 3, 5, or 7. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So, let's see. What do we have here? We have... two sets of digits. Actually, we have... We have this digit, which has a dot next to all 4 edges here. So therefore, that means it has to be a digit that's in a 1 to 2 ratio with 2 digits and is consecutive with 2 digits. Because you can only be consecutive with at most 2 digits, right? So the other two have to be in a 1 to 2 ratio. Therefore, if this were 2 or 4, this can only be 2 or 4 because those are the only digits that are in a 1 to 2 ratio with 2 digits. But if this were 2, it would have to be 1 and 4 in a 1 to 2 ratio and 1 and 3 in a consecutive. So that would not work. Therefore, this can't be 2. This has to be a 4. It's in a 1 to 2 ratio with 2 and 8. Which could be any of the digits, remember. The black and white are just for decoration, and they're consecutive with 3 and 5. So this could be 2, 3, 5, or 8. That means we have a 2, 3, 5, 8 quadruple in box 1, which means we eliminate 2, 3, 5, and 8 from the rest of the box. So it's 1, 6, 7, 9 in the remaining digits. Okay. Do we have any other ones that are like that? No. Everything else has at most 2 dots next to it. That means what other ones? We have 4 dots which are connecting 4 specific cells. Right? So each of the dots is in a relationship with 2 other cells in that relationship. Actually, let's not go that way. Let's go box 9. Well, yeah, let's go box 9. Every digit in this box is in a relationship with some other cell in the digit. That means that includes then every digit in that box, right? So that means 5, 7, and 9 have to be in some relationship with that box. So they're consecutive somewhere. 9 specifically, actually 1 also. So 9 and 1 have to be in a relationship with only one other digit. 9 is only in a relationship with 8 because that's the only digit it's consecutive with. It doesn't have a 1 to 2 ratio with any other digit. And 1 can only be in relationship with 2 because that's the only digit that it can have a relationship with because its 1 to 2 ratio is 2 and it's consecutive with 2. So where can the 1 and the 9 be in this box? Cannot be here, cannot be here, cannot be here, 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 or here. So this has to be a 1 or a 9, and this has to be a 1 or 9, which forces this to be 2 or 8, and this to be 2 or 8, right? Because those are the only digits it can be a 1 to 2 ratio. It can have a relationship with. Right? This has a relationship with 2 digits. This has a relationship with 2 digits. Same here, same here, same here, same here. Because it just goes along this route, right? Until here. This one has a relationship only with 1 digit here. This cell has only a relationship with 1. So this is 1, 9, 1, 9. It's with 2, 8, and 2, 8. Now, 8 can be in a relationship with, of the remaining digits, with 7 or 4. 2 can only be in relationship with 3 or 4. So this is 3, 4, or 7 here. 3, 4, or 7. That means, but it could be any of those, unfortunately. So that doesn't give us very much. Okay. Right, because so 5 could be either of these. 3, 4, 7 cannot be either of these, right? 7 can only be a ratio with 6 and 5. So this could be 3, 4, 5, and 6 here. This can be all of 3 through 7, right? Well, if this were 3 here, the problem is it would have to be next to 4 and 6 of the digits remaining, right? 2 is already taken. Right. And it would then, okay, I know it. 3, yeah, 3 would have to be next to 4 and 6. The problem is 3 being here, 4 being here would eliminate 2 possibilities for these 2 cells, and they would both have to be 7s. So this cannot be 3. If this is 4, it would have to be next to 3 and 6 here, because the 2 and 8 are already accounted for. So this can't be 3 or 4, period. And that would have the same problem, right? So if this is 4, it would have to be next to 3 and 5, because 2 and 8 are already taken. These would both then be 7, and that's not allowed. If you have 5, you have a 4 and a 6 here. 6 would be next to 7. The 4 would be next to 3. So 5 is possible here. 6 could be here if it's next to... It could be next to 3, 5, and 7, right? 7 is one of these two then. So if it's 6 here... No, 6 cannot be here. If 6 were here, the 7 could not be either of these, because the 7 would have to be next to 6 and 8. Oh, the 7 does have to be one of these two. Right? 7 can only be between 6 and 8. And since one of the 8 is here, because it has to be next to the 9, that means the 7 has to be here. And since the 7's here, that means 6 has to be here. And since 6 has to be here, it could only be with 3 next to 3 or 5. Well, 3 we showed can't be here because 3 has to be next to 4 and 6 here, which would make this 7 and 7. So this has to be 5 then. So this is 5. That means 5 cannot be here. 5 can only be next to 4 and 6. Therefore, that eliminates 4 from the rest of the box because of the 4, 6 pair. That forces us to be 3 and 7 here. Okay. The 6 has to be next to the 7. The 4 has to be next to the 3. So these are all the same set, right? It's either 4, 3, 2, 1 or 6, 7, 8, 9. Same with this. This is the same set. This cannot be the same set as the orange. If it is, well, no, hold on. It could be a 1 to 2 ratio. Could it, though? It'd be 1, 2, and 3. I don't think it could be 2, 3, and 6, right? If it's 2, 3, and 6. So it could be 1, 2, 3, 1, 2, 4. That works. It could be 2, 4, 8, though. Too many possibilities there. Okay. What else do we have? This set of digits that are 4 cells in a row. That means there has to be at least 1 1 to 2 ratio there. But so say you had 3 consecutive digits here, right? So it'd be like 3, 4, 5, 6. Oh, that does work. Huh. Okay. Okay, so 3, 4, 5, 6 would work as something like that. Right, because then the 3 and 6 are in a 1 to 2 ratio with each other. You could have something funky like 2 and 4 and 3 and 6 are... No, that doesn't work. You could have something like... Okay, 1 can never be here. So 1 can never be here because there's 2 unique digits there. 9 can never be here because there's 2 unique... sorry, they're next to 2 digits, and they're 2 unique digits here. So 1 and 9 cannot be here. So you have some combination of 2 through 8 here. The orange 1, 9 cannot be here, so the orange 1, 9 has to be one of these 2 cells. The yellow 1, 9 could be any of these, or it could be here. We don't know. That means the orange 1, 9 in box 1 has to be one of these 2 cells, which means the orange 1, 9 is one of these cells here. That's interesting. It would have to guarantee with the orange 2, 8, but we don't know where that is. So that's not that useful. One of the orange 2, 8 and the orange 3, 7 is in this. At least one of the orange 2, 8 and the orange 3, 7 is in this space. In these 4 Kropki dots. Okay, the orange 2, 8 has to be next to the... What can be here is kind of the question, right? So you have the digits 2 through 8 here. 5 could only be consecutive with 4 and 6. The thing is, if you have a 1 to 2 ratio between them, and you do have to have a 1 to 2 ratio between them, I think the thing is, if you have a 1 to 2 ratio, the only way you could have two 1 to 2 ratios if you have 4 or 2. 2 doesn't work because, again, these digits have a relationship with two other unique digits, and 1 can't be that. 1 is only a relationship with 2. 9 has a relationship with 8. That's why 1 and 9 can't be here. So that's why the orange 1, 9 is here. The other yellow could be in one of those 4 spots. But if you tried to have 2 in a 1 to 2 ratio with two other digits, it would be 1 and 4, and that would not work because 1 can't be in relationship with two other unique digits. So you could have something with 4. 4 is in a ratio with 2 and 8. 2 would then have to be consecutive with 3. And 8 would then be consecutive with 7 or 9. But neither of those can be. So you would have to have something like a 4 here. It would be next to 2 and 8. And then one of those would be consecutive with a 3, but the other one would be consecutive only with 7 or 9. And so that doesn't work as two 1 to 2 ratios. Therefore, you need only one 1 to 2 ratio here, and the rest are all consecutive. And the only way that works out is if it's consecutive. Well, 4 is consecutive with 3 and 5. 5 does not have another. The only way I think that seems to work is you have 3, 4, 5, 6, right? Can you have two digits that have a 1 to 2 ratio between them and then are consecutive with each other? And I think the answer there is no, right? Because they have to be consecutive with each other. And they then have to be in a 1 to 2 ratio with each other. Well, if you have a 1 to 2 ratio with one digit going this way, and a 1 to 2 ratio with one digit going this way, the problem is by just sort of identity, since this is, say, double this one, right? And then these would have to be the same doubling, right? This would have to be double that if that were the case. But that doesn't work, right? Because this would have a difference of 1. This would then have to have a difference of 2 because this is double that, right? So if you had, say, like 2 and 4 and 3 and 6, the problem is this is a difference of 1, but you're doubling this amount, and since this is a difference of 1, you're doubling this amount, it has to have a difference of 2 now, right? Just by how math works. And you can't go the other way, right? You can't go 2, 4, and, I don't know, 3, 6, right? Because even though this is a difference of 1, the problem is you're having this one, but you're doubling that one. So that difference is going to get greater. And you can't have 5 here. I don't know. It just doesn't work, I don't think. So it has to be 3, 4, 5, 6 here. Which means one of these is 4. And this is 3, 5, and 6 here. Right? Well, since this is 3, 4, 5, 6, that leaves in the rest, that's a 3, 4, 5, 6 quadruple in box 7, which leaves the rest of the box as 1, 2, 7, 8, 9. Since this is 1, 2, 7, 8, 9, none of the orange 1, 2, 7, 8, 9s can be here. Well, we have a 1, 2, 7, 8, 9 quintuplet, which eliminates 1, 2, 7, 8, 9 in the rest of the row. So this can't be 1, 2, 7, 8, or 9. Therefore, this is 3, which forces this to be 7. 7 can only be next to 8 and 6 with it has any relationship with. Therefore, that forces this to be the orange to be lows and the yellows to be highs. That leaves the rest of the digits to be 4, 5, and 6 in row 7. This is then a 4 here, and this is a 9. This is 1 and 2. That means 1 and 2 cannot be here. Therefore, this is a 1, 2 pair. 1 and 2 can only be next to 1, 2, or 3, or 4, but the 4 eliminates that possibility there. So this can't be 4. Where is the 4? This can't be 5 or 6. This is 3. That forces this to be 4. 4 can only be consecutive or in a relationship with 5. So this is 5, this is 6. This can't be 5 here, and this can't be 3 here. So one of these two is a 3. This 1, 2 pair eliminates 1 and 2 here, so this can't be 1. This can't be 2. 1 has to be one of these two digits, and 1 has to be one of these 3. Well, if 1 were one of these, this digit here, it would be 2 here, so this can't be 2. This can't be 1, so it can't be 2. So this is a 1 here, which forces 2 to be here, which eliminates 2 in the rest of the column. That forces a 5, 8 pair, so that eliminates 5 and 8 in the rest of the column. So this is 7 or 9. 7 and 9 can only be consecutive with 8. So this is 8. This can't be 8 here. This is 7 or 9. So of the digits here, only the digit 8 can be here. It could be 7 or 9, could be in a ratio with 6 or 8. And 8 can't be here, therefore this must be 6. This can't be 5 or 8 because of a 5, 8 pair in the box, so this is 3, which forces this to be 2. This is 6. 6 is therefore only in a relationship with 7, so that's 7. This is 9, this is 7. 6 can be in a relationship with 3 and 5, but 3 is here, so this has to be a 5 here. This 6 eliminates 6 as a possibility in the rest of the column. That leaves this as a 4. This 7, 9, this can't be a 7, 9 pair because of a 7, 9 pair in the box. That leaves this as 3, 8, and 9 in column 1. So now we've got all the 1, 2s here. This is 1, 2, or 3. 1, 2, and 3 can only be in a ratio with 1, 2, and 3. The only other digit remaining then is a 9. So this is 9. 3 has to be one of these two. So if this were 3 here, it could not be in a relationship with both 1 and 2. So this can't be 3. This has to be a 3 here. It's only in a relationship with 2, so that's 2. This is 1, this is 2. Out of 1, 2, and 3, right? The remaining digits here are 1, 7, and 8. So we have a similar problem here, right? You have 4 digits that are in a relationship with each other. You cannot have any combination except 3, 4, 5, and 6. So this is 3 and 4. This can't be 3 because of this 3. These can't be 3, therefore this must be 3. These can't be 4, so this is 4. 4 is only in relationship with 3 and 5 in this set. So this is 5. This is 6. That eliminates 4 and 5 here, so this is 6. This can't be 6 either case. That leaves in box 2, 1, 2, 7, 8, 9. 2 cannot be either of these. So 2 is one of these two. What else do we have? 1 has to be in a ratio with 2, which would then be in a ratio with 3 or 4. 1 cannot be here then, in box 5. 1 cannot be here, because the 1 would have to be with a ratio with 2, and the 2 could only be in a relationship with 3 or 4. And both of those are covered there. So this has to have a 1. So one of these is 1. It must be next to a 2, so this is 2, which means this 2 eliminates this 2. So that's a 1, that's a 2. And then it must be 3 or 4. It cannot be 3. So it must be 1 and 4 here. So this must be a 1, 4 pair, which eliminates 1 and 4 in the rest of the column. This can't be 1 or 2. Can't be 9. Because of the 9 in the column. This 1, 4 pair eliminates 1 and 4 here. This can't be 4, so this is 5, which forces this to be 4. This can't be 1, so this is 7 or 8. This has to be a 2 because of where the 2 has to be. It can only be here, which forces this to be 1 because that's the only digit it can have a relationship with. 9 then has to be here, which means 9 has to be one of these two here. It must be next to 8. 8 can only be in a relationship with 4 and 7 remaining, but we don't have the 1-4 pair in the box because, sorry, we don't have a 4 available because of the 1-4 pair in the box. So it must be 7. This can't be 7 because of the 7 here, so this must be 7 here, which forces this to be 9. Then we have 3, 5, and 6 remaining. 5 can only be next to a 6 out of 3, 5, and 6. Therefore, 6 is in the middle, 5 is on the outside, and then we have 3 and 5. This 7, 8 pair eliminates 7, 8 from the rest of the column. So this is 1. This can't be 1. This is 7 or 8 here. This is 9 here. This 1 eliminates 1 here, so that's a 6. This is a 1. This 9 eliminates 9 here. Okay. This cannot contain 3, 4, or 5. So what can this be? Two would only be in a 1-to-2 ratio with 1 and 4, and it can only be consecutive with 1 and 3. So 2 can never be on the inside, and 2 would have to be next to a 1, which could only be in a relationship with just itself. So 2 and 1 are not here. 6, 7, and 8 works. 7, 8, and 9 works. 8 can only be in a 1-to-2 ratio with 4. 6 can only be in a 1-to-2 ratio with 3, and those are already in the column, so that's not allowed. So this has to be 6, 7, 8, or 7, 8, 9. Well, this can't be 7, 8, and 9, or 7, 8, and 9, so this has to be 7 here, which forces 6 and 8 to be next to it. That means this is 6 because 6 can't be here, and this is 8. That 8 eliminates 8 here, so that's 3. This can't be 3 or 8, so this is 9, which forces this to be 8. This 4 eliminates 4 here, so it's 1 and 4. 3 eliminates 3 here, it's 5 and 3. That leaves 1 and 2 here. This can't be 1 because of this one, so this is 2, this is 1. We have 3 and 4 remaining here. And this is what? 5 and 9. This can't be 9 because of the 9 here, so this is 5, this is 9. We have 2. We have 8 2s. We know where the last 2 has to be. It has to be here. We have 1 and 9 remaining here. 1 can't be here. Actually, I think that's 8 1s, right? We have 8 1s. We know where the last 1 has to be. It has to be here. That forces 9 to be here in column 9. This 9 eliminates 9 here. It's 7 and 9. The 7 eliminates 7 here, so that's 8 and 7, which forces this to be 8. This can't be 8 or 9, so that's 7, which forces this to be 9. This 8 eliminates 8 here, so it's 5 and 8. We have the digits here are 7 and 8. 7 cannot be here, so therefore this must be 7. This has to be an 8. The remaining digits in row 3 are 3 and 4. Now, which digit is here that has a relationship with 8? It's only 4. So, because 3 is not 1-to-2 ratio with 8, it's also not consecutive. So this is 4, this is 3. That forces this not to be 4, so this is 3 and 4. And we have 5 and 6 remaining, which forces this to be 6 and this to be 5. And that's a solution, a bad Kropki. Interesting. It was interesting to have this, to deduce this information here. And this one actually was kind of interesting also. This was a fairly easy break-in. And this being, yeah, so the idea of which digits can be next to what dots is very interesting, I think. Particularly without the coloring being in question, I guess. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.